Greetings, Earthlings. Welcome to a video on trig identities. One of two, not one half, one of two videos. The second one will be coming soon. This is part of an analytic trig unit where we analyze. But don't judge people. Oh my goodness, don't judge. Judging is not so good. That's not going to get you anywhere. Judge yourself, why don't you? Look in the mirror, see what it's all about. I am here to train you to analyze. I want your analytical skills to be amazing. Just like when you studied geometry, when you learned about proofs, it wasn't the geometry that was the sole purpose, the sole part of what you were learning. It was understanding a logical argument and how you could go from one step to the next step and understand how the pieces come together. And geometry is a lovely thing to do that in context. So, trigonometry is a wonderful thing to improve your analytical skills. Oh, you were pretty good at your analytical skills in geometry if it went well for you. So, that's what one of our main focuses will be in this particular unit. First four topics, really. Before we go any further, I'd like you to pause this video and do a quick review. I just want you to check out these two factoring questions and see if you could factor them completely. Pause me. Okay, I'm back, folks. I hope you paused me. And how about pause me if you want to share an answer out loud before you go here. But anyways, you should know that this is factored into two binomials. And I know you're excited about number two. We'll get there. And we know that one of these must be 2a, the other one must be 1a. And one of these must be 2, and one of these must be 1, the remaining pieces. And in fact, it goes something like this. All right, so that'll give you the answer. Now, did you go all the way? Did you go all the way with this second piece? This is the product of a squared minus b squared and a squared plus b squared. I realized recently that your textbook, or many official documents, like to write the negative piece first, meaning this a squared minus b squared instead of the other way around. It's like such a cup half full. You know what I'm saying, Chloe? This is crazy. Chloe's such a positive person. She would never stand for that. So here we go. We're going to go all the way there with this. Then you could factor it a plus b, a minus b, and multiply that by a squared plus b squared. Oh my gosh, did you get that? If you did, I'm so proud of you. It's amazing. I know what you're thinking, Max. Give us more of those. Give us more of those. We love those. Nope. We're moving forward. Okay, so we're gonna focus on reciprocal identities. Now this is kind of a review, and the video is gonna go kind of quick from here. So just pause or rewind a little bit if needed. But we have another one to take a look at. So we're on page 3 here. It's nice and structured for you, and so we're gonna get these 6 identities here. The first one goes something like this. Cosecant theta is 1 over sine theta. And alternatively, sine theta equals 1 over cosecant theta. I know you know these. Jot them down anyways. So that's a pair. Secant theta is 1 over cosine theta. And cosine theta is 1 over secant theta. So this page is ultimately going to be a nice reference guide for all of the puzzles that you're going to try to solve. Okay, and then the third one, cotangent theta. Cotangent and tangent are unique because they're reciprocals and cofunctions, 1 over tangent theta. And then tangent theta is 1 over cotangent theta. There are your 6 basic reciprocal identities. So you got your main identities at the bottom, sine, cosine, tangent, and your reciprocals of those. Okay, next up, we got quotient identities. These are brand new to you, and we just have 2 of them. The first one goes something like this. The fact that tangent theta, oh nice and big, this is great, I guess not for you. Tangent theta is the ratio or the quotient of sine and cosine. Hey, that's special. I wonder why that is. And then the other one is cotangent theta is just flipped upside down. So these ones are pretty nice. I like them. Some of my favorites. You know, you gotta have some favorite identities. You know, one of my other favorite identities being the husband of Lisa Stark. It's a good one. It's a good identity to have. Mathematician. I like that one. But notice, you know, when you divide sine theta by cosine theta, you're basically dividing opposite over hypotenuse divided by adjacent over hypotenuse. So the hypotenuses cancel each other off, and you get O over A, opposite over adjacent, which is tangent. All right, so those are those two. Those are just kind of hanging out by themselves, and we'll go to the final one for this video, is the Pythagorean identities. Pythagorean identities. Hey, these are super cool. I love these as well. The first one is my favorite one, and we actually have three, but you only have two spots for them, so we're going to just write the one in the bottom. So sine squared theta plus cosine squared theta equals 1. Hey, just a little side note. The way that I wrote that notation, sine squared theta, sine 2 theta with a superscript. If you ever become a math teacher or do any mathematical notation in the future after high school or college, you might use Google Docs or a Word document and you'd use a superscript. Well, sine squared theta is just a shorthand notation for sine theta quantity squared. Okay? So that's just a shorthand for that. Now that's not equal to, not equal to sine theta squared. That's bad. No, we don't like that. I'm going to try to do this as an audible here. So see if you could stick with me. I'm going to divide everything, well, I'll just write one thing. Divide everything by sine squared theta. Okay? And I'm going to get a new identity. So that means I'll get 1, because I'm dividing that, sine squared by itself. Now cosine squared over sine squared is cotangent squared theta, based on our recent quotient identity. And if you divide 1 by sine squared theta, you get cosecant squared theta, using the reciprocal identity. All right, so that's the first one, the second one, and there's one more. And for the last one, we're going to divide by cosine squared theta. Meaning, we're going to divide the first one, the first equation, okay, the first identity. Sine squared theta divided by cosine squared theta. Oh, what is that? That's tangent squared theta. Cosine squared theta divided by itself is 1. And 1 divided by cosine squared theta is secant squared theta. So this is going in that note beneath the line for you. So that's our third one. Now the most common with some of our work is sine squared plus cosine squared equals 1. That literally means if you sketch both graphs on the same axis, it'll just be a straight line. They'll always add up to 1, as long as you square them. That's super unique. I like that. And it's Pythagorean because it's like a triangle. It's all based on triangles. Okay, those are the three. Those are Pythagorean identities. We're memorizing the first one right away, today. We're memorizing the first one. The other two will flow whenever we see squared things. We're like, oh, I think that's a Pythagorean identity. And we'll reference this. All right, so you got 6, 8, plus 3, 11 identities. What I want you to focus on memorizing is the quotient ones and the Pythagorean identity number 1. Fantastic. All right, I have more identities in the second video, so check that out. And don't get burdened by that. It'll work out just nicely. And remember, don't judge. Analyze. Bye-bye.